Hello class, I hope you're having a wonderful day. Today I would like to complete one of the practice problems that goes over calculating the peak runoff rate on a piece of property pre and post development. So this is a pretty lengthy problem, so what I've done is I have typed up the problem in the description. So please read the description and just follow along with me. And as we're going through the problem, what I want to do is point out some of the knowns that are given to us, and then we will go over the items that we need to calculate. So a family has recently purchased a 9,992 square foot plot of land that was originally pasture in Dallas, Texas. Okay, so here we have our pre-development area of 9,992 square feet located in Dallas, Texas, and the land type is categorized as pasture. The family is having a house built with a single roof covering 2,602 square feet of the property and having 1,351 square feet concrete driveway installed. So next item that we have, area of the shingle roof is 2,602 square feet, and the area of the driveway is 1,351 square feet. Use the rational formula to determine the peak runoff rate of the property prior to development, so this is known as pre-development, and after the addition of the home with the shingle roof and concrete driveway. This is known as post-development. Use the National Oceanic and Atmospheric Administration, so the NOAA, table to find the rainfall intensity for a 25-year 1-hour rainstorm for Dallas County, Texas. Okay, so here we have all of the given information that I've provided a known column for you, and I've outlined that in green. And then we're going to have to calculate A through K, which I have identified in the description section. Now, the first thing that I want to cover before we start calculating anything and looking information up in our tables that are given to us, let's go over the rational formula. So our rational formula, this is identified by Q. So Q is equal to C sub F times C times I times A, okay? So Q represents the peak runoff rate, and we're going to calculate this for the pre-development situation and the post-development situation. C sub F is our runoff rate adjustment factor, and this is based on the return period of the storm, and we're going to cover this in a moment. C, this is our runoff rate based on the type of surface, so how it's categorized, and this is pasture. I, that's the rainfall intensity, and we're going to have units in inches per hour. Next, we have area. This is going to be in units of acres. Okay, so for our runoff rate coefficient factor based on the return period, we just have a numerical value, no units. Next, we have our runoff coefficient based on the surface, how it's categorized. Once again, just a numerical value, no units. So we're going to wind up with units. We have inches per hour times acres. Algebraically, we know that this is acres over 1. So we have an important conversion. 1.0 acre times inches per hour is equal to 1.008 cubic feet per second. Okay, so that is one of our important conversions that we're going to need to use. So we're going to be performing dimensional analysis here. And then another important conversion is going to be 1.0 acres is equal to 43,560 square feet. Okay, so we're going to be given units for area in square feet, but we're going to have to use dimensional analysis to convert that into units of acres to plug into our equation. Okay, all right, so first thing we need to do here in part A it wants us to identify the rainfall intensity for the 25-year 1 hour rainstorm. Now, what this means is this is the most powerful 1 hour rainstorm that occurs every 25 years in Dallas County, Texas. So what we're going to do is we're going to use the NOAA table for Dallas County, Texas, okay, and I've provided this to you in Canvas and I've given this to you in class, okay. So what we're going to do is we are going to look at the intersection of the row and column. So we're going to take a look at the 1 hour row. So in this NOAA table, it's 60 minutes. We know that 60 minutes is 1 hour. And we are going to follow this row over to the 25-year column. So our value is 3.07 inches per hour. So in part A, that's going to be our answer, 3.07, and we have to use units of inches per hour. The units are very important, okay? And then in part B, it wants to know what the runoff coefficient adjustment factor is. So this is identified by C sub F, and remember, I mentioned that this is based on the return period of the storm. Well, here we have a 25-year rainstorm, so the most powerful rainstorm every 25 years. So looking at the runoff coefficient adjustment factor, down the left-hand column, the return period is 25 years. And then in the right-hand column, we have our numerical value for the runoff coefficient adjustment factor. It is 1.1. So our answer here is 1.1. Okay, so I'm going to erase this. We'll need to come back to this. But next, we are going to calculate the runoff coefficient for the pasture. Okay, so what we're going to do, since our soil type is categorized as pasture, we're going to take a look at rational method runoff coefficients table. And once again, I provided this table for you electronically in Canvas and in class. And we're going to go down to the categorized by surface, and we have pasture. So our lower value is 0.05, and what we're going to do is average the lower and the upper values. So our lower value is 0.05. Our upper value, and we're going to add these together, is 0.3 divided by 2. So we have 0.35 divided by 2, and that's going to be 0.175. So our value for our runoff coefficient for the pasture is 0.175. Okay? Next, area of the pasture. So this is pre-development. So remember, the family purchased an area of land, 9,992 square feet. So we've got area of the pasture, 9,992 square feet. What we're going to do is use dimensional analysis. We need to convert from square feet to units of acres. So we know in 1.0 acres, we have 43,560 square feet. Okay, our units of square feet are going to cancel. That's going to leave us units of acres here. So let's get out our calculator. And let's do 9,992 divided by 43,560 square feet, and that's going to give us 0.22938 acres. Okay, so what let's do is let's just write that answer over here. So 0.22938, and we have units of acres. Okay, so I'm going to go ahead and erase this because I'm going to run out of room here. Next, we need to calculate the pre-development peak runoff rate. And once again, we are using this rational formula given to us. So what we're going to say is Q sub pre. Now I'm going to use the subscript of pre here just to be clear that we're calculating the pre-development runoff rate. So what we have is C sub F times C, and I'm going to be specific with the subscript because it's Pasture, times I times A. All right, so we have a numerical value for the runoff rate coefficient adjustment factor, and remember this is based on the return period of the storm. It's once every 25 years, so it's the most powerful storm every 25 years in Dallas County. Our numerical value is 1.1. It is unitless. Next, we have the runoff coefficient for the Pasture, and we just calculated that a few minutes ago. 0.175. I is our rainfall intensity, and this is 3.07 inches per hour. Yeah, 3.07 inches per hour. And now we're going to multiply by the area of our land. And remember, this is pre-development. So our pre-development area is 0.22. 938, and we have units of acres. Okay, so we're going to take the product of these four values here, 1.1 times 0.175 times 3.07 times 0.22938, and this will give us, for our pre-development peak runoff rate, of 0.13556. But we have a problem here. We're not done because our units are in acre inches per hour. Okay? So we can't use this here. We have to use dimensional analysis to convert this into units of cubic feet per second. So what we're going to do is we are going to multiply by 1.008 cubic feet per second, and we're going to divide this by 1.0 acre times inches per hour. Okay, and you can see that our acre inches per hour, that unit will cancel. So we're going to multiply this value by 1.008, and this will give us, I'm going to go ahead and write the answer here, this will give us 0.13664 cubic feet per second. Okay? All right, moving on. Next, now we need to identify the runoff rate, the runoff coefficient for the shingle surface. Okay, so this is going to be post-development. Okay? So for post-development, we're going to have two surfaces that the rain is going to contact. Now, besides our pasture, okay, so the rain is going to contact the roof and the concrete driveway. So what we're going to do, once again, we're going to take a look at our table, rational method runoff coefficients. And right here in part F, we're looking for the shingles. So categorized by surface. The last row in this category is titled shingle roof. Our lowest value is 0.75. So C sub shingles, 0.75 plus, all right, our value on the high end is 0.95. And we're averaging them, so we're going to add both values, then divide by 2. This will give us 0.85, and this value is unitless, okay? Now we need to calculate the area of the shingle, so this will be the area of the roof that rain contacts when it rains, okay? It's given to us as 2,602 square feet. So once again, we're going to use dimensional analysis. We are going to convert the units from square feet to acres. So we have 1.0 acres is 43,560 square feet. You can see that our units of square feet will cancel. And this will give us 0.05973, and we are left with units of acres right here. Okay, next we need to identify the runoff coefficient for the concrete. So we are going to take a look once again at the rational method runoff coefficients. Okay, so we're looking at concrete, and in the second to last row, under the categorized by surface, it says 0.8, so C sub concrete. We have 0.8 plus, we have 0.95, and then we're going to add those together and divide by 2. So 0.875, so 0.875 will be the average there. Okay, here, let me do this on the calculator. 0.8 plus 0.95 divided by 2, 0.87. Okay, all right, so our average value, so our lower end is 0.8, upper end is 0.95. We're going to add the two values, divide by 2. Our average is 0.875, and once again, I just want to say that it is a unitless value. We just have a numerical value. Okay, so the area for the concrete driveway, it's given to us in units of square feet. So 1,000, here, area of concrete driveway, 1,351 square feet. We're going to use some dimensional analysis to convert from square feet to units of acres. In 1.0 acres, we have 43,560 square feet. You can see that units of square feet will cancel, square feet in the numerator, square feet in the denominator. So once again, let's grab our calculator here. 1,351 square feet divided by 43,560, and that will give us 0.03101, and we have units of acres. Okay? All right, I'm going to go ahead and erase this here. Next, we need to calculate the composite coefficient. Okay, so what we're going to do is we are going to calculate the peak runoff rate post-development. So Q sub post is equal to our runoff rate coefficient adjustment factor based on the return period of the storm multiplied by our composite coefficient. So using the composite coefficient, we are going to combine all three areas. So post-development, we have area of our pasture, we have area of the driveway, and we have area of our shingle roof. We're going to combine those three together using an equation for C sub C, and I'm going to come back to that in just a moment. Multiplied by I, which represents rainfall intensity, times the total area. Okay? All right, so now I want to talk about this composite coefficient. C sub C is equal to area 1 times the runoff coefficient for area 1 plus area 2 times the runoff coefficient of area 2 plus area 3 times the runoff coefficient for area 3. And all of this is divided by the total area. Okay, so well, we've got area 1. We can call this area of the pasture. Okay, and I'm just going to rewrite our variables here. So I've got area of the pasture times the runoff coefficient of the pasture plus area 2. This is going to be area of the roof. Yes, area of the roof times the runoff coefficient of the roof plus area of the driveway times the coefficient, the runoff coefficient of the driveway, all divided by our total area. Okay? All right, so just in short, like I mentioned in class, what we could do is we could multiply the percentage of the area, like we could add up the percentages of the area together to calculate the total runoff rate post-development. But that's going to be 3 different equations, then we're going to have to add those together, and it's a very long, drawn-out process. So we are using a shortcut method by using this composite coefficient. So we're combining the areas together and then using one equation to calculate the peak runoff rate for post-development. So here we go, area of the pasture. We started with, where's our area of the pasture? We started with 0.22938 acres. But remember, we built a house and a driveway here. So we're going to have to subtract the area for the roof and the area for the driveway. So what we have is we're starting out with the area of the pasture, 0.22938 acres. We're going to subtract the area of our shingle roof. So 0.05973 acres. And then we are going to subtract the area of our driveway. So minus 0.03101 acres. And then multiply by the runoff coefficient for our pasture surface, 0.175. Plus, now we're right here. We've got area of the roof. Okay, area of our shingle roof is right here, 0.05973 acres times our runoff coefficient for our shingle roof. And remember, we use the average value, 0.85. All right. Ooh, I'm running out of room here. So, plus area of the driveway. So we calculated the area of the driveway in units of acres. So 0.03101 acres. And we are going to multiply that by our runoff coefficient for our concrete driveway, which is 0.875. Then we're going to divide all of this by the total area. Our total area is right here. This is the area of our pre-developed land, so 0.22938 acres. Okay, so just to make this clear, what I want to do, I just want to do a piece at a time here, okay? So we're getting the area of the pasture, so pre-development pasture minus the area of our roof minus the area of our driveway. And then we're going to multiply that by 0.175. So let's do that first. Let's just do this step by step here. Okay, so I get 0.13864 acres times 0.175. And I'm going to get a value of 0.02426, and we're going to have units of acres, okay? So right here, this value is 0.02426 acres. Plus, next, we're going to take the product of these two values. So I've got the area of the roof, 0.05973 times 0.85. This is going to be 0.05077 acres. Plus, now moving on here, the product of the area of the driveway and the runoff coefficient of the driveway. So I've got 0.03101 times 0.875. This is going to give me 0.02713 acres. And remember, all of this is divided by the total area, 0.22938 acres. Okay? So what I'm going to do is I'm going to add the three values in the numerator, and then I'm going to divide it by the total area. And you can see that the units of acres will cancel because we're going to have acres in the numerator and acres in the denominator. So okay, so in the numerator, I get 0.10216 acres. Then we're dividing it by the total area, 0.22938 acres. So divided by 0.22938. And this is going to give me, and I'm just going to write the answer here, 0.44539. And once again, this is unitless because the units of acres go ahead and cancel out for us. Okay? Now, what we need to do is calculate the post-development runoff rate now. So we've got this value. I'm going to go ahead and erase this, and we're going to go back to our rational formula here. Okay, so once again, using our rational formula here, C sub F represents the runoff coefficient adjustment factor. That's based on the return period of the storm. Numerical value 1.1 times our composite coefficient. So we're taking the three areas and combining them into one. We just calculated that, 0.44539. We're multiplying this by the rainfall intensity. We looked this up in the table earlier, 3.07. We have units of inches per hour. And our total area, here we are right here, 0.22938 acres. So we're going to take the product of these values here. And we are going to get 0.34501, and we're in units of acre times inches per hour. We need to perform some dimensional analysis here. Remember that in 1.0 acre inches per hour, we have 1.008 cubic feet per second. So in our numerator, 1.008 cubic feet per second, and we're dividing by 1.0 acre times inches per hour. So acre inches per hour, that goes ahead and cancels. I have this value stored in my calculator, so times 1.008, enter. And our post-development is equal to 0.34777 cubic feet per second. Okay? Now, the question is really asking, what is the change in peak runoff? So what we're going to do is we're going to compare our pre-development peak water runoff rate to our post-development peak water runoff rate. So let me just write the equation here. I've got delta Q, and so remember our Greek letter delta represents the change in, so what we're saying is the change in peak water runoff rate. This is equal to Q post minus Q pre, okay? So our post-development runoff rate, we just calculated that right here, 0.34777. We have units of cubic feet per second minus our pre-development runoff rate. So we calculated this value earlier. So pre-development runoff rate right here, 0.13664, and we have units of cubic feet per second. So let's use our calculator again. I have this value stored in my calculator, so I'm going to say minus 0.13664 and delta Q. So the change in peak runoff rate is equal to 0.21113 cubic feet per second. Okay, so what this means is after we develop this land, so we've purchased this piece of property in Dallas, Texas, then we built the house on it. Now after development, our peak runoff rate, there's an understood positive sign here. So our peak runoff rate has increased 0.21113 cubic feet of water per second for runoff rate. Okay? All right, so I know there is a lot to this problem. I know I talked a lot about this in class, but as always, if you have any questions at all, please email me. You can give me a call. You can contact me over Canvas. If you have any questions, let me help you, okay? I hope you have a wonderful day.